Hello everyone, welcome to our daily physics problem, day 5. So today we have a very classic problem about block stacking. So if you stack 4 identical blocks with mass m, length l on top of each other, and we want to let the top one move outward a little bit compared to the down one, what is the maximum distance x, which you can extend out between the first and the last blocks. So we have 1, 2, 3, and 4 blocks. So first I want you to pause the video to try on your own. After you tried, come back to the video and let's see how I did it. So welcome back guys. So as I said, this is a very classic problem. Why is classic? Because we need to think backwards at this moment. It's called, in computational science, we call it recursive thinking. We think about the simplest form of this question and then we develop recursively from the last to the first. So what do I mean by that? Let's see the situation between the first block and the second block. So in the simplest form, where there's only 2 blocks, how are we going to balance the 2 blocks without falling down? So we need to think that the center of mass of the first block have to line up with the edge of the second block. So that will be the maximum distance that extend out between 2 blocks. So let's define as x1 will be equal to L over 2, because the center of mass of L, the first block, will be right in the middle of the block. Then let's think about the 3 block situation. As we have the first block, second block, third block. Distance from the first block and second block is x1. Distance between the second block and third block is x2. So between second block and third block, you find x2. Then we need to apply a little bit of torque here. So first, let's think of the center of mass of M1 and M2 have to line up with the edge of block 3, just like we did before in the first simplest situation. Then we apply a force, the mg, which is the force exerted on the first and second block, and let's define the edge of block 3 as our pivot point. So we can list out a balancing for torque equation. Mg times x2 is equal to mg times L divided by 2 minus x2. And L over 2, which is the distance from the center of mass of the second block to the edge. Then we solve for x2. Cancel out mg is equal to L2 minus x2. Then x2 will be equal to L over 4. So x2 will be equal to L over 4, distance from second block to third block. Now we already solved 3 of the blocks. It's time to solve 4 blocks. Oops, that's a mistake. Okay, the fourth block situation. So you might think if the first block, second block is 1/2, third is 1/4, the third to the fourth have to be 1/8, right? But actually that's not the case. So let's see what happened here. So let's first define our blocks: the first block, second block, third block, fourth block. And we'll talk about distance from third block to fourth block. Let's define it as x3. So actually we have the same process as the first situation, second situation. We need to use some balancing of torque. So in this situation, we know that the center of mass of the first and second and third blocks have to line up with the fourth block's edge. So we have the block 3 have a force exerted on its M2, the mg, and the force exerted on the center of mass of 1 and 2 block, it's 2 mg. And we can define our center of mass, center of pivot point at the edge of 4. Then we can solve for x3. Just like we show, x3 will be equal to L over 6. L over 6. So now we can solve for x. X will be x1 plus x2 plus x3. Then we plug them in. Will be equal to. Let's simplify the. Let's have our common denominator, which is 12. Okay, let's plug in 12. There will be 6 over 12 plus 3 over 12 plus 2 over 12 times L. That will be equal to 11 over 12 L. And that will be our final solution.